In this video, we're going to review what a series is. Here you see a definition. A series is the terms of a sequence added together. So whereas a sequence might be 3, 5, 9, 17, and so on, going off into infinity, the series looks exactly the same except instead of commas, we have addition signs. So 3 plus 5 plus 9 plus 17 plus ... means that this continues off into infinity. We've looked at two types of series. We've looked at the series when we have an arithmetic sequence, and these were the two formulas that we developed. Remember, they're kind of the same thing. This one is used when you know the first term, the last term, and the number of terms to be added together. And the second formula you can use when you don't know the last term, when you're only given the first term and the number of terms to add together, but you also know the common difference between the terms. So really, these are the same thing, but instead of u to the n, we've put in the formula for u to the n for the general term of a sequence. The other series that we've looked at are geometric series. And these were the two formulas for geometric series, also two types that you can use. This one is an exponential function. So you see here you have to take r to the n, where r is the common ratio, u1 is the first term. And Sn is the sum of n terms. So you put however many terms. If you want to add up 10 together, this would be Sn. If you want to add up 5 together, this would be S5. The same thing goes for these formulas too. These are really the same thing. They are exactly the same thing. There's only a factor of -1 difference between in the numerator and the denominator. So they're really actually the exact same formula. This one is slightly easier to use if r is bigger than 1, because then you get a positive number in the denominator. And this one is easier to use if r is less than 1, because you get a positive number in the denominator. Okay, those are the two types of series we've had. Let's look at some. In this first example, an arithmetic sequence has u1 equal to 5 and u5 equal to 17. We know we're looking for the sum. We're asked to find the sum of the first 50 terms. We also know that the sequence is arithmetic, and we know our first term and our fifth term. So we know we're looking for a sum. That tells us we're going to use the S formula and not the U formula, and we're looking for an arithmetic sequence. So going back, we're going to choose one of these two formulas, and which one we choose depends on the information we have. So far we know n is equal to 50, and we know u1 is equal to 5. u5 doesn't show up in the formula, so that's not helpful to me. But now to use one of these formulas, I either need to know un, the last term, the 50th term in that case, which I don't have, or I need to know the common difference, which I don't have either. So one of those I'm going to have to be able to find out using u5. Well, the common difference I might be able to figure out the easiest by looking at the difference between the first and the fifth term, and then saying I've got a number of terms between there, and then figuring out what the common difference is. There are a couple of ways of doing this. The one way by hand is to say, okay, I've got u1, u2, u3, u4, u5, and this one is 17, and this one is 5. That means I've added 1, 2, 3, 4. I've added 4d to get from 5 to 17. So I'm going to start with 5. I'm going to add the common difference 4 times, and that's going to give me 17. And now doing that, I have a formula that I can solve for d. So 4d is equal to 12 by subtracting 5 from both sides, and that means d is equal to 3. So my common difference is 3. The other way of doing the same thing is to use the formula for a sequence. So if I use this formula that we've already worked with, plug in everything I know, and then solve for d, I'll get the same thing. un, that's going to be my fifth term, using n is equal to 5. So that's 17. u1, I know, that's 5. N I know because I'm on my fifth term, and then D is what I'm solving for. So then I also get the equation 17 equals 5 plus 4D, right? And from there it's the same thing, the same algebra that I just did over here, and I get D is equal to 3. Okay, either way is fine, either way works. Choose the way that makes most sense to you. So now I know also my D. N, U1, and D, the formula that involves those three things is the second one. So I'm going to choose that second formula and continue with this problem. Okay, and then I'll need my data again. And since I can't see it, I'll just write it here once more. U1 is equal to 5, N is equal to 50, and D was equal to 3. And then I substitute the parts, these values into the formula. So the sum of the first 50 terms is going to be 50 divided by 2, with 2 times the first term, which is 5, plus 50 minus 1 times 3. Then work through it very carefully. Before you put it into your calculator, I would recommend simplifying a little bit so that you don't have so many brackets and numbers to put in. So 50 divided by 2 is 25, 2 times 5 is 10, this is 49, and then I multiply by 3. And so now I can build it up in my calculator. Let's do the 49 times 3 first, find out what that is, then add it to 10, hit equals at that point, and then multiply the answer by 25. And that should give you, see, this is 147, 157, so 157 times 25. I forgot to turn on my calculator, so I'm going to do it the long way. So you can check to see that I didn't make any mistakes. I get 3,925 as the sum of 50 terms. Okay, let's look at another example. In this example, we're asked to consider a series. We don't know whether it's arithmetic or geometric at this point. We're just told 4 plus 12 plus 36 plus 108 plus a whole bunch of numbers plus 26,244. So we know our last term, but we don't know how many terms are in between. We don't know what n is. And actually, that's what we're asked to calculate first. Calculate the number of terms in the series, so that's our n equals something. And we have to calculate the sum of the series. So there we're looking for Sn equals something. Notice I do these things to help myself remember what I'm doing, so I don't have to keep rereading the question. Those are good tips for writing the exam too, that you make little notes to yourself on the paper. None of that's marked, of course. Only the answers in the answer box are marked. Okay, we know what our first term is, so we can write down U1 is equal to 4. But the big question is R or D. Maybe you can tell by looking at it. If you don't have a common difference, if I subtract 12 minus 4 and compare that to 36 minus 12, then I get 8, and here I get 24. So there's quite a difference between that. So there's no common difference. So since we only know two types of series, we're going to assume this is a geometric series. And in that case, then I would find R by dividing consecutive terms. So compare 12 divided by 4 with 36 divided by 12. Right? Always take the second term divided by the first term, third term divided by the second term, or we could do fourth term divided by the third term, and so on. It's easiest to take the small numbers. So 12 divided by 4 is 3, and 36 divided by 12 is also 3. So R is equal to 3. That means this is, of course, geometric. So if I go back to my page of formulas, then what do I need for a geometric series? I need the first term, I need R, and I need n. So I'm not ready to do the sum yet. I first have to calculate the number of terms anyway in order to do B. So I'm going to calculate the number of terms by using the UN formula. So if you remember, that one is U1 times R to the n minus 1. So I have my last term, 26,244. I can't quite fit everything, so yeah, okay, that's correct. And that's going to be equal to 4, which is my first term, times R, which is 3, times n to the minus 1. And now I need to solve for this. So that's of course a little tricky because the n is in the exponent. So either we have to use logarithms, which we haven't talked about yet, or we're going to use graphing in order to find that. So to make that easier though, to make the number smaller, I'm first going to divide 26,244 divided by 4, and we get 6,561 equal to 3 to the n minus 1. And now I need to know what power of 3 is going to be equal to 6,561. I could start just calculating powers of 3, right? I know 3 to the 1 is 3 and 3 to the 2 is 9. So 3 to the 3 is 27. And then I can just multiply by 3. 27 times 3 is 81. And 81 times 3 is 243. And then to the 6th power is 729. And to the 7th power, it's 2,187. We're getting close. And there we go. 3 to the 8 is 6,561. So there's my answer, that 6,561 is equal to 3 to the 8. That means that n minus 1 is going to be equal to 8. So n must be equal to 9. I can check that. 3 to the 9 minus 1 in my calculator is 3 to the 9 minus 1. And that is equal to 6,561. So that works, and n is equal to 9. So that's the number of terms I have. That was the answer to A. And B, we can use that information now in order to calculate the sum of this series. So U1 is 4, R is 3, and n is equal to 9. One thing I should say, I did this the long way and didn't show you it by graphing because I don't have the calculator software installed yet to be able to show you that on the screen. But you can solve this by graphing too, right? You would put your Y1 as 6,561 and your Y2 would be 3 to the x minus 1 in your calculator. And then you have to watch out for your window. Your y has to go all the way up to 6,561. So your y I would put maybe between 0 and 7,000. And your x, we don't know what we're going to get yet, so probably 0 to 20 is a good idea. You won't get x's that are much higher than 20 in your exam. Usually you can do them this long way if you want, and so that's the data you should use if you're going to put it into your calculator. Okay, let's go back to part B. So I need the formula for the sum of a geometric series. So we're going to go back to this page and go down and take this formula first. Okay, and let's put it in here so we can see it. Oops, I didn't have the S of n attached there, so let's put that back on. So we need our first term, S of, in this case, 9 terms. The sum of all the terms we were given is 4 times R is 3 to the 9 minus 1 over 9 minus 1. And then I simply multiply that out. Again, I would simplify what I can before putting the whole thing into the calculator. So I'll do 3 to the 9 as a nice big number. So 4 times 19,683 minus 1, and then 9 minus 1 is 8. So minus 1 times 4 divided by 8 equals 9,841. And that's the sum of the 9 terms. So let's go back and make sure we answered the question. It was reflect, right? Calculate the number of terms in the series. Yes, we had an answer for that. N was equal to 9. So there are 9 terms in this series. So if this is 4, then I'm missing 5, 6, 7, and 8 before this is the 9th term. And then I had to calculate the sum of the series. And does that make sense to get 9,841 when my one term alone was 26,244? That doesn't make sense. I'm going to have to go back and see what happened. So did you see what I did as we were going along? I decided to leave this in. I could have redone the example and just left and corrected it so you didn't see me make the mistake. But it's a good idea to show you sometimes that I also make mistakes and how it's really important to go back and read the question and see that what you have makes sense. I picked up the fact that I'd made a mistake because if I'm summing all these terms together, my answer has to be at least bigger than 26,000. And I got an answer that was smaller than 26,000, and so I knew I had to go back and check. Now, if you look at how I substituted for the formula, whoops, let's go back. Okay, you might have seen this as we went along. This says r minus 1, but what did I plug in here? I plugged in n minus 1. So that's the part that's wrong, and I hope that wasn't confusing while I was going through it, but this should not be 9, this is 3. And that, of course, makes this 8 a lot smaller. That makes this 2. And now I can delete this altogether. And that number I had of 78,728, I can divide that by 2 instead of by 8, and then I get an answer of 39,364. And that's much more reasonable because that's bigger than 26,000, but not so much bigger that it doesn't make sense. Okay, that's the end of the examples. Now you've seen a couple of examples and how to catch your own mistakes. Hope that helps you a little bit with your studying.